Welcome to this combined concept and examples video for area of a triangle using Trig, where we go over what it is and how we do it. This should be a shorter video because it's quite a small topic. So when we're first introduced to area of a triangle, we're usually given the height of the triangle and the base of the triangle, and the formula we learned previously is the area is just half the base times height, and this should be a formula you're familiar with. But what happens when instead of being given the height of the triangle, we're just given another side and the angle between the two sides? Well, this is what we focus on in that 5, and let's have a look and see if we can get to the equation that we use in that 5. So we're going to take this part of the triangle out and have a look at it. And this dotted side here is just the height. So let's see if we can get an expression for the height, because the height is what we need in our equation. So this is a right angle triangle here, where we've got two sides and an angle, so we can use SOHCAHTOA to find the side we need. And we want the opposite, so we'll tick them off, and we've got the hypotenuse, so we'll tick them off as well. And from this we can see that we clearly need to use sine. So we want to find the opposite, and the opposite is just the hypotenuse times the sine of the angle. And the opposite h is then equal to the hypotenuse, which is a, times sine c. And if we take this expression in front of h and plug it back into the original equation, we can replace that equation with one in terms of a and c. So all I've done here is replace h with just a sine c, because that's what it worked out to be. And if we just rearrange these terms a little bit and change the colour, we can see that this is just the area equation that we get in that 5. So you don't need to know how it gets to the equation because you're given to an exam. I just think it's interesting and useful to see how we get to it from the old equation that we learned. Now let's go and have a look at a few examples so we can see how to use this equation. So in this example here, we're given two sides and an angle, which is exactly what we need to work out the area. So let's find the area of this triangle. Let's label the 5 as being the A, and the 7 as being the B, and obviously the angle as being the angle C for our equation to work. So let's take these values and sub them into our equation. So the area is just equal to half times A, which here is 5, B, which here is 7, and sine C, and C here is 105. If you pop that all into your calculator, you can do it in multiple steps, or you can do it all at once, but either way it should come out to be 16.9. And since I didn't put any units in the question, I've just wrote units squared afterwards. And that's just to remind that if it was in metres, we put metre squared. If it was in centimetres, we put centimetre squared. Just remember that area has got dimension of unit squared. Let's go on to look at some past paper questions. So this question is just asking us to find the area of a triangle. It's only worth 2 marks, so hopefully it's not too difficult. And we can see that we're given two sides, so let's just label them A and B. And instead of being given the angle that we need, we're given the sine of the angle. But that's fine because that's what we need in our equation for area. We're asked for sine C. So we'll just call this sine E. That's our sine C that we're going to use in our equation. And that's quite a common theme throughout non-calc papers. If they want to test you some trig stuff, they'll just give you sine or cos the angle rather than asking you to find it. Okay, so the area is the half times our A and B, which is 8 and 12. And then times sine C, and sine C here is just 2/3, like it's given in the question. Let's work this out in 2 steps. So let's do a half times 8 first, which gives us 4. And then the 12 times 2/3 gives us 8. And the way you do that, non-calc, is just divide by 3 to give you 4, and times it by 2 to give you the 8. And that gives us 4 times 8, which is just 32. And in the question, it was in centimetres, so we need to remember to put our answer in centimetres squared. Let's go on to the next one. So this one's our 5 marker, so it's going to be a few more steps, likely. And unfortunately, the diagram they're giving us hasn't got all the information we need, so we need to read the actual question to get more information. So let's have a look. We've got a sector of a circle embedded, or just inside essentially, of a big triangle. And let's mark on the stuff that we need. So it's telling us that radius is 30, so let's mark that on. So that's this distance here. And the angle, AOD, which is just the angle next to the O, is 35. And it's telling us that in the triangle, OB is 38, so let's mark that on. And it says that OC is 55, so let's mark that on also. And the shaded area is the one that I've just cut in there, just to make it clear and obvious. And we notice that the area of the whole shaded area is just going to be the area of the triangle, take away the area of the section of that circle. Because that shaded area is just an entire triangle with just a circle bit removed. So let's work at the area of the triangle first. So the area of the triangle, and we'll redraw the triangle that we've got. And I've labelled on the two sides and the angle. And we can just plug these values straight into our area equation. So the area of the triangle is just the area of the triangle equation. I mean, we plug our values in. And you pop that in your calculator, it comes out as 1009.4. And now the area of the circle is obviously just pi r squared, but it's a sector area, so we need to times it by the angle over 360 as well, because it's just a fraction of the circle. And plug in the numbers there, we've got pi times our radius 38 squared times the angle 75 over 360. So the area of the circle comes out to be 588.8, and then we just find the area of the shaded area by taking the circle area away from the triangle area, and that comes out to be 420.6. And remember, again, in the question it says centimeters, so we'll leave our answers in centimeters centimeters squared. That brings us to the end of this short video on area of a triangle using trig. I hope you found it useful.